Well, good afternoon. Just a couple of odds and ends today. I'm still waiting for another replacement piece for the logic analyzer. I got the inverter board, tested it, it worked, nibbled out some space because it wasn't the exact same one, put it in, stopped working. So I had to buy another one because I think it just failed. So we'll get the new one, we'll check it, and we'll see whether it meets spec or not. Anyway, while we're doing that, I just thought I'd show you a couple of things that have come that I've got that I haven't done a video on yet. The first is this cool device here, and this comes from a viewer of the channel. Bought a bunch of these in a auction, and so he sent me one for free, which was very nice. It's Miroslaw. I really appreciate that. This is an ET2266, and so we'll take a look at that. The next thing we're going to take a look at is some of this new old stock stuff that I managed to pick up. This is a 478A 50 ohm load Terminator, and this here is actually the replacement part for a Thermistor, which is this guy here. So we'll take a quick look at those. I think they're interesting primarily, not because they're anything unique, but primarily because of the documentation that's in there. But let's take a look at this guy. Now, this thing here, as you can see, is an ET2266, and I'm led to believe this is a pulse generator, and it'll have around about a 3 microsecond pulse rise, which gets you the bandwidth required over 100 meg to check a scope. Now, I know nothing about these, and there's nothing on the internet, the interwebs about it. So I asked the guys on the HP forum, and what they pointed out was that ET is a designator that's designed for internal built tools. So one of the old HP guys there said that he thought this would have been something that would have been working on the oscilloscope production line to test the scopes, but it shouldn't have this GR874 connector on it. And so what I think somebody's done is come in and they've got some form of fire cell somewhere, and they've replaced that connector. Now, you have the normal you have the normal N-type connectors that you get. These things were used because they're they're like a quick connect. You effectively can just plug them straight in, and they'll give you a good connection. And there's none of the twisting and turning and so on, and then all of that work. And they were basically a sexless connector, sort of like an APC7, but not again designed specifically for metrology. Anyway, we can see that this is going to be a pulse generator of some format, because what we have here is we have a trigger out, we have a trigger level set, or a trigger speed, I'm guessing, and then we have some shape and amplitude controls. And so I'm assuming that what they did was they set the trigger to be some point, took out from here to the trigger of the scope, and then took that out into the front of the scope so they could check to see what the reaction of the scope was, and then this would let them dial down the amplitude of the signal. Anyway, let's take a look at the back. As you can see, they've used this is a very standard look and feel for the case design of the era. So let's just take that out. And we'll take a quick look inside. Let's zoom in a little bit. Okay, so starting at the back here, we can see transformer, the power supply. You can see there's one long board that runs up the side here. So basically we're going to have the first part of this is going to do the power supply part of it, and then these two boards up here are going to be the output part, or the actual working bits of the unit. This is probably going to be the trigger circuitry in here, and then this is going to be the pulse amplitude or the pulse amplifying circuitry part in there, and then you can clearly see that this is going to be the attenuator of some format. So what? Oh, that's interesting. So what we want to do is just plug it in and see if it works. Now, before I do that, let's turn it over and take a look. So you can tell this is an example of where somebody's had the unit apart, where they've got completely mismatched screws. Now, I noticed this when I was looking just in there, but this should make sense. If we look here, there's going to be, looks like a ground connection for this cap here is not connected. It's broken off there. So we'll need to get in there and fix that before we try and turn this guy on. So let's go in and we'll take out this side panel here. I don't know if it doesn't look like there was, it looks like that is just turned around the wrong way, and that should be connected to here. But I don't know if there's any actual component missing there. The guys are saying that there's virtually no chance of ever getting a schematic on any of this ET type gear. It stands for electronic tool, I'm led to believe. And you won't get a schematic on it because they were all custom created. And you can see that in the layout of the tracks and everything. And so we're pretty much guaranteed. Oh, no. So here's what's going on. This is I think had a bit of an accident in transit. That shouldn't be bent in there a little bit, and then these two should push up against each other. Let me take a quick look and see if that's actually a solder joint. Okay, so having a look a little closer, and now getting in, and let's zoom in a bit, see if we can get. There we go. You might just be able to see. You can see there's a hole in here. So there's actually a component that was in between those two items, and so I do not know what it would be. I suspect, given that that's a bloody big cap, it might have been a like a little resistor. Anyway, rather than, let's see if we can just get it. Well, let's plug it in and see what will happen here. Uses one of these oval, I think they're PHY 183 connector. Anyway, nope. So this thing seems to be dead-ish. Okay. Okay. 250 milliamp. Okay, so, oh, there we go. We saw just quickly the little lights come on there. So, might be able to just give this a little quick test and see if anything is coming out on it. Okay, well, let's turn it on, see what the... Let me get my other camera in here so that we can all see what's going on with respect to the oscilloscope. Okay, so let's turn it on. Oh, well, there we go, that's interesting. So that's trigger out. I don't know what the trigger advance seems to do, but it seems to just simply deform that waveform a little bit. Okay, let me see if I can get something to pick up the other channel there. Yeah, there's clearly nothing coming out of that attenuator there. So we're taking a little look, see if we can probe into there. We're not getting anything at all, but we are getting trigger out. So that sort of implies that this part of the thing is going to be working. So anyway, turn that off. It's a nice little project to do a little bit more of a tear down of this unit, and then be able to see if we can work out what is going wrong on here. So if I look, I don't know if that's even soldered in. Anyway, that was an interesting look there. Let's drop this stuff out of the road for a moment, and then we'll take a look at our other two items. Let's do the simpler one first. This is your classic 50 ohm load and or 50 ohm terminator, and so you put that on the end of a end of things like a dual directional coupler or anything that you want to terminate into 50 ohms. And this is like an RF. This is a an RF Terminator. So this is a model 478A. This was very, very inexpensive on eBay, which is surprising because it has a very good SWR. The SWR on this from DC to 4 gigahertz is 1.05, which is a nice SWR for a Terminator. It gives you a good impedance match there. So this is the document that, as we can see, and that's pretty much it. There we go. But this was new old stock, was how it was sold, and it looks to be in very, very good condition. You can never have too many proper working RF Terminators, so I'm sort of happy with that. We can see inside here, inside this housing part here, I've done a teardown of one of these before, I think maybe a 909A, but inside here you'll have the resistor, and that's where there is serviceable parts. You can take it apart and replace it. It's usually not worth it though, because the parts to get in, especially as they progressed in their later versions, where they started using ceramic composites as the resistors and so on, made it very expensive to get the parts. Alright, the next bit is this replacement part here. Now, I got this because you've seen me do, you've seen me show these parts before. This is the 478A Thermistor mount, and these are good because they are give you an ability once you've calibrated to do a direct measurement of power. You don't need to have a reference set or reference point set to a known value. You can use the device itself. Now, the problem that you get with a lot of these is that people have put way too much power into them and they blow the thermistor mount up. And so I happened to be looking at eBay one morning, and this Thermistor assembly, which is the replacement part that goes in here, was available. It was available for sale, and it was $30 or so. Well, that's cheaper for me than buying a whole new thermistor. So I thought, what the hell? Let's go buy that thermistor mount. And so here, let's take a zoom in, and we can see what the thermistor mount looks like. So let's get right in there, and here you can see there's two thin wires that go into the actual head here, and then there's some additional circuitry. Now this is eventually, to characterize all of this, should end up at 200 ohms. So you want to be able to check that, and there's a process of doing it where you take the original sensor and you can measure across the thermistors. Now, one of the thermistors, if we look over on the other side, you can see the cavities there. One of the thermistors will be inside the RF area, and it'll be measuring the power from the RF device that's being fed in. And the other thermistor will be outside of that area and isolated from that power, but still be impacted by the thermal impact of this thermistor. And so that way you can use those two thermistors with a bridge to be able to work out and get rid of the thermal effects, not exactly, but get rid of the thermal effects of any measurement that you're taking. So I'm quite happy for that. I don't want to take this guy here apart because I have this guy calibrated, and if it breaks, then I will repair it, get it working again, and then send it off to Keysight to be calibrated. Here is you can see the original, let's see if we can zoom in on it. It's the original part number for that thermistor assembly. And then let's zoom back out and take a look at the actual documentation. Now, this should explain the process to go in and replace that thermistor mount. So here we go. I'm going to go check the thermistor out. You can see here this was the where you would go and you'd put your voltmeter across here. You'd measure that it's 200 ohms effectively. You want to make sure the match is very good. And then there's a procedure for recompensating once you've done an install. So here's what this unit here will look like on the inside. You can see that we have this guy here is basically going to be attached to this front part here, and then those wires are going to come back and connect to the back mount here. And we can see quite a bit of information about the layout, what it is, how to assemble it, some notes using the thermistor replacement kit. Sound conductor made by a bellows. If the bellows does not contact the sound conductor, the SWR will be about 2 at 10 gigahertz. So you can check to see what the SWR, to see if you've got a good match on that. It's pretty interesting. And here you can see the full blow up of how this is going to all connect in, I guess. You know, so you're going to have this go into the connector assembly. You know, you can see the little bolts that are coming in there. It's very nice. So, not very dynamic, but still, it's nice to be able to get some of this stuff. I wonder if people get this and just have it sitting around and then sell it, or if there is really some broader, like, you know, they have a, you know, did somebody do like I did, and let's buy it just in case something happened to their thermistor mount, and then never used it. Anyway, I hope you like the look of that. We'll come back in a later video, hopefully after I've gotten my extra spare part to replace this guy that's blown up. This was the original dead one. This worked twice and then died. Once we've got that, we'll fix the logic analyzer, and we'll see how we go. We might come back and see if we can get an amplitude pulse out of the front of this. Anyway, if you like that, give it a thumbs up. Otherwise, I'll catch you later.